With millions of potential points of contact on the ground below, trees, buildings, people, a storm can single out one specific target with terrifying precision. Lightning is far from a random event. Its path is dictated by a high-speed sequence of electrical interactions that happen well before the flash we see. A lightning strike is a high-stakes, two-sided race. Both the cloud and the Earth are aggressively reaching towards each other at phenomenal speeds. To understand why a specific tree or radio antenna gets hit, we have to look past the bright flash. The answer lies in the invisible tension building up in the air long before the strike ever occurs. This image shows a cumulonimbus cloud dominating the sky. Inside the central core of this massive structure, violent updraft winds are constantly crashing tiny ice crystals into soft, dense pellets of hail. This cross-section reveals what happens after those collisions. The friction strips electrons, separating the charges. The ice crystals become positively charged and are carried to the top of the cloud. The heavier hail becomes negatively charged and gathers in the lower parts of the storm. Now look at the bottom half of the graphic to see the mirrored reaction on the Earth. As that heavily negative cloud base hovers overhead, it repels the negatively charged electrons in the ground below. This forces the ground to become intensely positive. This creates an invisible magnetic pull between the negative cloud base and the positive ground. Physicists refer to this growing tension as the electric field. The air between the cloud and Earth reaches a breaking point. This separation of charge creates a massive electrical potential that must be explosively resolved. The sky makes the first move. Pushed by the pressure of the electric field, a faint channel of negative charge steps out from the storm base. This is the stepped leader. It drops in violent, jagged spurts, lunging downward about 160 feet at a time. Each microsecond step is followed by a 50-microsecond pause to scan the electric field, looking for a target before taking another blind step. This invisible scout carries a staggering payload. It drags an avalanche of electrons, holding an electric potential of about 100 million volts. As it pushes closer to the Earth, the leader fractures. It branches out in tens of thousands of directions, feeling its way through the air to find the path of least electrical resistance. The storm is frantically reaching downward, testing every possible route in the sky, desperate to feel a magnetic response from the ground before it runs out of momentum. Down on the surface, the Earth is an active participant in this process. As those 100 million volts approach, the localized electric field becomes overwhelmingly strong. The downward pressure pulls the Earth's positive charges up, concentrating them into the highest, sharpest points available. When the field strength crosses a critical threshold, it triggers positive streamers. These are invisible ionic channels of positive charge that shoot upward from trees, buildings, and even people, rising into the air to intercept the descending leader. The microsecond a single upward streamer comes into contact with any branch of the downward leader, the two sides lock together. This is called attachment. It instantly forms a single, continuous, low-resistance wire between the cloud and the Earth. The blinding 30,000 ampere flash we see is the return stroke. It travels up the established channel from the ground back into the cloud. It happens in a fraction of a microsecond, deceiving the human eye. The strike we witness is the Earth violently discharging its energy back into the sky along the winning path. The physics of these upward streamers explains why tall, pointed objects usually win the race. Being physically closer to the cloud base allows them to experience the strongest electric field and launch their streamers first. But the stepped leader's descent is chaotic. Because it branches blindly in thousands of directions, a downward branch might randomly wander closer to a shorter object, allowing its upward streamer to close the gap first. There is also a dangerous anomaly known as positive lightning. Instead of originating from the negative base of the cloud, these strikes launch from the highly concentrated positive ice crystals at the very top of the storm. They are known as bolts from the blue. Because they drop from the highest altitudes, they can travel for miles horizontally through clear air. They carry significantly higher peak currents, heat surfaces to extreme temperatures, and strike completely without warning. While the connection process usually follows predictable proximity rules, the sheer scale of a thunderstorm's stored energy means no outdoor location is entirely immune to the unexpected. This is why standing in an open field during a storm is incredibly dangerous. Without any taller structures nearby to intercept the electric field, your body becomes the highest point, making you the prime launcher for an upward streamer. Lightning rods take advantage of this physics. By being the highest point on a structure, the rod is designed to launch the strongest, fastest streamer first, capturing the strike before it can hit anything else. Once it wins the race, the rod routes the immense charge down a heavy conductive wire, dissipating it safely into the earth and bypassing the building entirely. A lightning strike is an explosive finale. The storm separates the charge, the sky blindly reaches down, and the earth aggressively reaches back. It is a precise, invisible sequence of physics choosing its champion.